Ladies and gentlemen, good morning. My name is Rob, and I will be your conference operator today. At this time, I would like to welcome everyone to the Database Administration Process Session, Common Errors, and Their Possible Root Causes conference call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. Mr. Andrew Xavier, Senior Manager of Oracle America, you may begin your conference.
All right, thanks, Don. Hello, everyone. Thank you for joining us today. My name is Andrew Xavier. I'm the Senior Manager here. I'll be hosting this session for you. Our speaker today is Amir. Amir is a Tier 1 engineer with the database admin team. He's been with Oracle from 2006, working in multiple areas of expertise. As an advanced resolution engineer, he handles many of the complicated customer issues, provide training and coaching across multiple disciplines. We also have Abraham, Nishant, Ralph, and Bharat in assisting in our QA section. We expect today's webcast to approximately 60 minutes, including a brief Q&A session. The session is being recorded, and at the end of the session, I will go over when and how we can access the recording and the question and answers from the webcast today. Questions can be submitted to me through the presentation via the Q&A panel. Your questions will be collected and read aloud during the QA portion of the call in the order they are received. To aid in question collection, please only submit your question once. If you are listening via voice streaming and lose sound, go to Communicate Audio Broadcast to restart the streaming audio. Should you still encounter difficulties, please dial into Intercall directly using the numbers provided in the reminder email. I also entered the information in the chat box for you. Any questions that remain unanswered at the end of the session will be transferred to the community where you can continue the conversation. So first thing first, please remember this advisor webcast is intended for information purpose only. Any features or functions described for Oracle product remain at the sole discretion of Oracle. With that, Amir, if you're ready, I will go ahead and do the transfer to you.
Yeah, thank you, Andrew. This is Amir Tadros from the DB Admin support team. I'm the principal technical support engineer in this team, and I'm acting also as a global technical lead. I'm happy to go with you through this webcast about the quick troubleshootings of the common errors that the processes and sessions may encounter. So here is our agenda for today, objectives. We are willing to identifying the root cause for some common errors for the processes and sessions. And we will be learning how to troubleshoot, fix, and proactively avoid them. Here is the agenda. These are the errors we are going to cover in this webcast. The first one is the Aura 20 error, which indicates the maximum number of processes exceeded, and the Aura 18, the maximum number of sessions exceeded. Aura 445, the very known error message, which is background process did not start after some seconds, and the different Aura 273 errors. Let's start with the Aura 20 error. So why is this error raised? This error is raised whenever a new process spawn is attempted, although the maximum number of processes is reached. So we are trying to fork a new process when we have already reached the maximum limit of the predefined maximum number of processes. And this maximum limit is defined by the processes initialization parameter. What are the possible reasons for the ORA20 error? The first reason may be a misconfiguration of the process's initialization parameter. The second reason could be misconfiguration of the application and database connections. And the third one is the third-party program that could be spawning processes unreasonably. The fourth reason could be a misconception of the sessions processes formula. This misconfiguration includes the following areas. The number of user processes at the peak time may not be properly considered. If this number is expected to be around 1500, it will not be enough setting this parameter, for example, to 300. The number of Oracle background processes may not be considered while planning for the value of this parameter as well. Sometimes only the user processes may be considered. However, it is very important to note that the processes initialization parameter should include any Oracle process that is running on the instance on the server box, whether it is a user or a background one. How does a client connect to a database? So, as you can see in this diagram, we have here the client, and this is database listener, and this is the database itself. So when a client sends the database a connection request, this request is actually received by the listener, with which the database service is registered. The listener then checks the requested connection type and finally hands off the client connection to a server process. In such phase, the connection is established directly between the client and the database with no more listener engagement. There are two types actually for any connection. So number one is dedicated server connection, and number two is the shared server connection, which was previously known as the MTS, multi-threaded server connection. How can dedicated connection lead to ORA20? So if the actual number of processes at workload peak time frames exceeds the expected one, and the connection type is dedicated, then this can end up with the ORA20 error. If we are using the shared servers, this can be more effective in such case. So here is an illustration how the dedicated server architecture looks like. So in a dedicated server architecture, a 1-to-1 ratio exists between the client process and the server process. Even when the user is not actively making any database requests, for example, an idle connection, the dedicated server process remains. Underutilized dedicated servers sometimes result in inefficient use of operating system resources. Consider an order entry system with dedicated server processes, and a customer places an order as a clerk enters the order into the database. For most of the transaction, the clerk is talking to the customer, while the server process dedicated to the clerk's client process is idle. The server process is not needed during most of the transaction, and the system may be slower for other clerks entering orders if the system is managing too many processes. For applications of this type, the shared server architecture may be preferable. Let's check the shared server architecture. So in a shared server architecture, a dispatcher directs multiple incoming network session requests to a pool of shared server processes, eliminating the need for a dedicated server process for each connection. An idle shared server process from the pool picks up the requests from a common queue. So here is the common queue. In a shared server configuration, client user processes connect to a dispatcher. The dispatcher can support multiple client connections concurrently. Each client connection is bound to a virtual circuit, which is a piece of shared memory used by the dispatcher for client database connection requests and replies. The dispatcher places a virtual circuit on a common queue when a request arrives. An idle shared server picks up the virtual circuit from the common queue, services the request, and relinquishes the virtual circuit before attempting to retrieve another virtual circuit from the common queue. This approach enables a small pool of a server process to serve a large number of clients. A significant advantage of shared server architecture over the dedicated server model is the reduction of the needed system resources, enabling the support of an increased number of users. The potential benefits of shared server are as follows. Number one, reduces the number of processes on the operating system. So a small number of shared servers can perform the same amount of processing as many dedicated servers. Number two, reduces instance PGA memory. So every dedicated or shared server has a PGA. Fewer server processes means fewer PGAs and less process management. Number three, increases the application scalability and the number of clients that can simultaneously connect to the database. Number four, may be faster than the dedicated server when the rate of client connections and disconnections is high. The shared server has several disadvantages as well, including slower response time in some cases, incomplete feature support, and increased complexity for setup and tuning. And this is the most drawbacks of the shared server configuration, the complexity of the setup and tuning. As a general guideline, only use the shared server architecture when you have more concurrent connections to the database than the operating system can handle. The processes which are needed in a shared server architecture are: number one, a network listener that connects the client processes to dispatchers or dedicated servers. The listener is part of the Oracle Net Services, not the Oracle database. Actually, as a note, to use the shared server, a client process must connect through Oracle Net Services, even if the process runs on the same computer as the Oracle database instance. The second needed processes is the one or more dispatcher processes, which are DNNN. So the dispatcher background process is prefixed always with the capital D letter. The third needed process is one or more shared server processes. So the processes that are needed are a listener process, one or more dispatcher, one or more shared server processes. A database can support both shared server and dedicated server connections at the same time. For example, one client can connect using a dedicated server, while a different client connects to the same database using a shared server. And this can be managed through the SQLnet configuration files, for example, the tnsnames.org. For even better resource management, shared server can be configured for session multiplexing, which combines multiple sessions for transmission over a single network connection in order to conserve the operating system resources. Session multiplexing available with Oracle Connection Manager enables multiple client connections to funnel through a single protocol connection. For example, several client processes can connect to one dispatcher by way of a single connection from Oracle Connection Manager. Oracle Connection Manager allows communication by users to the dispatcher by way of a shared connection. At any one time, users might need the connection while other client processes linked to the dispatcher by way of the connection manager process are idle. Session multiplexing is beneficial because it maximizes use of the dispatcher process connections. Session multiplexing is also useful for database link connections between dispatchers. The limit on the number of sessions for each dispatcher is operating system specific. And because the Oracle Connection Manager requires some SQLnet skills, it is not supported by the DB admin support team. This is for your information. It is supported by another internal team called the Oracle Networking team. How to enable the session multiplexing? It's very easy. Just specify the multiplex parameter as on for the dispatcher's initialization parameter. In case a server process is done with its job and then becomes idle, if it is a dedicated server, we are losing one available process that can be used. While there should be no problem if it is a shared one, as it will then pick up another request from the queue, the common queue, to serve. So the shared server configuration is more effective in the following situations. The first one is huge number of user processes is expected to be spawned at peak time frames. The second case, if there is no accurate estimate of the maximum number of processes at peak time frames. The third one is the OS resource depletion that could arise in case many databases operate on the same server, which highly utilize the operating system resources. Another good alternative is the DRCP, which stands for the Database Resident Connection Pooling. This architecture actually uses dedicated server processes, but in a pooling fashion. As shown in the figure, when a client requires database access, the connection broker picks up a server process from the pool and hands it off to the client. The client is directly connected to the server process until the request is served. That's why it is dedicated. After the server has finished, the server process is released into the pool. The connection from the client is restored to the broker. So this is a very good resource efficient architecture, and at the same time using dedicated servers. This is the DRCP, Database Resident Connection Pooling. The third reason for the ORA 20 error is that some third-party applications unreasonably spawns huge number of processes. And we have seen this problem especially with the JDBC connections. And this is actually beyond the Oracle database scope and should be fixed through the application vendor who designed this application and this application database connections. Such problems have significant intents when dedicated server processes are used. The fourth possible reason for the ORA 20 error is the misconception of the sessions processes formula. So simply the formula that we are all aware of is sessions equal 1.5 multiplied by processes and added to 22. Some DBAs expect that the number of processes will automatically increase whenever the value of sessions is increased or vice versa to keep this formula always valid, and this is definitely incorrect. This formula just explains how the default value of the sessions initialization parameter is calculated if it is not explicitly specified. But any subsequent changes for either the processes or sessions go independently. Manual adjustment will be required then. How to troubleshoot the ORA 20 error? First, check the $V resource limit view, which shows the C limit for many resources, including the processes, along with its current utilization at the time of the query. Second, check the $V processes view to check how many processes, whether they are background or user processes. Third, check the $V session view, especially the column that is named server, because it will show you whether this session has been established with a dedicated server process or a shared server one. And data in the $V resource limit, $V process, $V session can be useful only during the time frame of getting the ORA 20 error or at the peak time frame. Inspecting these views outside this time most probably will not be adding value to this investigation. For RCA, which stands for root cause analysis, when problem no longer exists, but we would like to know the reasons for the ORA 20 occurrences, AWR report, the automatic workload repository report, or the ASH, the active sessions history report, may shed some light on how many sessions were there during the problem time frame, but there will be no clue about the server process type, whether they are dedicated or shared. An excellent reference that helps in configuring the application connections to the database can be found in the following Oracle Database Concepts documentation. It is a very, very excellent chapter. I recommend that every one of us reads it. So we are done with the ORA 20 error. Why is it raised? Possible reasons and how to troubleshoot it. Let us move to the ORA 18. So ORA 20 was maximum number of processes exceeded. However, ORA 18 is maximum number of sessions exceeds, not processes. In this error, it is for sessions. So why is it raised? This error is raised when a new session is about to be created when all the session state objects in the instance are in use. So we are unable creating any more new sessions. and this maximum limit is defined by the session's database initialization parameter. How is the maximum number of sessions calculated in multi-tenant environment? I would say even general, even if not multi-tenant environment, in any environment. So the maximum allowed number of sessions is chosen among the following values, whichever is greater. So we always are aware of the sessions initialization parameter value. But actually, internally in our Oracle code, we check this parameter value, and we check the default value as well, the formula 1.5 times processes added to 22. And whichever is greater among these two values, we will consider it as the maximum allowed number of sessions. So sometimes a DBA sees that the number of sessions, he decreased it from 500, for example, to just 7 sessions, and tried to create session number 8. And it is not erroring out with Aura 18, simply because this is not the maximum allowed number of sessions, because the default value is 1.5 multiplied by the processes initialization parameters and added to 22. So whichever value is greater, we consider it the maximum number of sessions, and once the maximum number is exceeded, we raise the Aura 18. And this has been confirmed by our development team in this bug. Maybe this is not quite clear in the documentation. We can make it clearer in the future, but this has been confirmed in a very recent bug, and this is the bug number. How to troubleshoot the Aura 18? First, check the value of the processes and sessions database initialization parameters. Second, evaluate the default value of the known formula. Then compare these two values and pick up the greater value to identify the maximum number of sessions we are considering in our code. Then select count star from the $v session view at the time of the error to see if the Aura 18 error was reasonably reported. ASH and AWR reports can show the total number of sessions during some time frame in the past, provided that the relevant AWR snapshots still exist, that they were not purged. We are done with the Aura 20 error. We are done with the Aura 18 error. Let's move forward for the Aura 445 error. And it's actually a very common message we see in the alert log file. It's very important we understand why it is being raised. So the first question, is it really an error message? Well, Aura 445 is not an error message. Instead, it is a timeout warning 1. This timeout message is posted in the alert log file after waiting for a predefined period of time. By default, this period of time is 120 seconds, which is equivalent to 2 minutes, for a new process to be forked or spawned. So it's not an error message. It's a timeout warning 1 that is indicating we have been waiting for at least by default 2 minutes waiting for a process to be spawned. So does Oracle fork processes itself? The answer is no. So at the end of the day, Oracle does not fork processes itself whenever needed. Instead, it sends such requests to the operating system to fulfill it. If for one or more reasons the operating system is unable satisfying this request within the predefined period of time, we raise the Aura 445 timeout message at the database level to notify the Oracle database administrator. These two concepts are very important because we we have a lot of service requests covering the ORA 445 message, and we have been seeing many customers considering the ORA 445 as an error message when it is not an error, and they believe that Oracle is responsible to spawn the operating system processes when this is not also correct. So Oracle database is a program running on a platform, the operating system, who is forking these processes whenever needed, the operating system, based on the request sent from the Oracle database. These concepts are very important in understanding this error message. So what are the possible reasons for this timeout? There are actually wide range of possible reasons for this timeout. Some of them are related to the database, some of them are related to the operating system, some other reasons for the storage, and other possible reasons related to the network. So the first one is too much activity on the machine, whether this is from the database or from the OS. So there could be a bottleneck on the machine, the server box. It could be database bottleneck or an operating system bottleneck. The second one could be an operating system slowness in starting up new processes. And I myself have seen this problem, although they are very rare, but they exist. And I have seen this with some of the operating systems. The operating system was very slow in spawning this operating system process to serve the need for the Oracle database. And as I mentioned, we are timing out by default after 120 seconds, which is equivalent to 2 minutes. So I would consider operating system process to be spawned after 50 seconds to be a longer time for an operating system process to be spawned. This is a very long time. So we even wait for beyond this long time period and wait for 2 complete minutes. And the third possible reason is a local storage I/O slowness. And the fourth reason is network file system latency, if it is used, NFS. And the fifth reason could be some network latency problems. So I would advise you not to focus on the ORA 445 message. It is actually an indication that something else could be experiencing slowness. So just consider it as an alert for you and try to search in all these wide range possible reasons what could be the reason for the ORA 445 message. So how to increase the time span we wait before raising this timeout message? So as we have mentioned that the default time we wait before which we raise the timeout is 120 seconds. How to change this by default? There is an event, it's 10281, and this has to be set at the system level, alter system, set event 10281, trace name, context forever, level, and you specify the level. And the level is actually the number of seconds to time out at. So I don't recommend changing this default time span before which we raise the timeout. But this can be used in some business. It will only suppress the error before being raised in the alert log file, but it will not fix the root cause which we have presented here in the previous slides. So if you are willing to get rid of this error message in the alert log file, you can use this event, but it is not recommended as it will not fix the root cause of the problem. How to troubleshoot this error or this message, first identify the time frames from the alert log file when the ORA 445 was reported. Second, get 30 to 60 minutes at most AWR reports covering the ORA 445 occurrences. And it is also worthy mentioning here that we do not rely on any AWR report whose elapsed time is beyond the 1 hour, because some of the statistics in the AWR report can be overflow. So we just consider AWR reports when the elapsed time is between 30 to 60 minutes. So identify the time when the message is reported in the alert log file, get AWR reports corresponding to this time frame, then check the database time in the header of the AWR report. So this is the elapsed time that should not exceed 60 minutes. It is here 45.24 minutes, and this is the database time. It is here 14,299.97 minutes. And this database time can indicate whether or not there was considerable database activity. Few thousands of minutes per hour or more would be considered a considerable high database activity. And then you can check the top wait events, whether you can check the top wait events in the AWR report, and then check were there any concurrency during this period, any latch contention, and queue contention, lock contention, etc. If there was any such contention, then this may lead to the ORA 445 timeout message. In this case, work out on avoiding such a database performance bottleneck, and this will consequently avoid the ORA 445 timeout. If there was no considerable database activity concurrency problem in the AWR reports, then get the listener log file, and we usually inspect the .log format rather than the XML format, and check for any TNS errors that might have taken place during the ORA 445 occurrence time frame. ORA 445 timeout can occur if there is a corresponding network timeout as well. That's why we should be inspecting the TNS errors. If there was no considerable database activity or contention and no TNS errors in the listener log file, then we should check the kernel configuration on the database server. This can be done through the HCVE report. HCVE stands for Health Check Validation Engine report. And here is the document that explains how to generate it. And usually some customers are confused among the HCVE report and the RDA. So whenever we ask for HCVA, we receive the RDA. Actually, HCVA is part of the RDA, but it is not generated in the general or the generic RDA. So we have to follow this document to generate the HCVA. How is the HCVA report useful? It checks several configurations that includes comparing the actual kernel configuration to the minimum recommended ones as per the Oracle database installation guide. So if we are below this minimum recommended values, we should be increasing the values. There is also considerable possibility for an operating system bug if none of the previously investigated areas is found culprit. So, for example, if there is no database activity, no networking problems, and no kernel configuration problems. So there could be a possibility of OS defect or bug. And we have here a very good tool. So in such case, the OS vendor should be engaged in this analysis. One of the Oracle tools that may help in this context is the OS Watcher. And this is a downloadable and free utility that captures the performance matrices from the operating system side, and OS Watcher does not require any special license, so it's completely free utility we offer to you. We are done with the Aura 20 errors. We are done with the Aura 18. We are done with the Aura 445 timeout message. Now it's time for the Aura 273 errors. So generally, Aura 27 errors are OS-related issues. So we are lacking of OS resources whenever we have Aura 27, etc. errors, especially the Aura 273 errors. So these are usually caused by operating system call error or operating system configuration issue, and are in the following form. So you can see here Aura 27300, Aura 27301, and Aura 27302. Sorry. So this shows the operation and shows the status. Can you see this? The operation that failed and the status of the failure. And here also the operating system failure message. And here the failure occurred at which operating system call. So these are very useful error messages by which we can identify the operation status, OS message, failure message, and the OS system call error. Depending on the status number, the problem can be narrowed down. So for example, you can see here that the failing operation was something called socket. This is for sure an OS term, not a database one. And here is the status for the failure, it is 11. And here is the OS failure message, it is resource temporarily unavailable. And here is the OS system call that failed. And this status indicates the number 11. This status indicates that the maximum number of kernel processes that are allowed per OS user may be too low. For example, the max UPROC on AIX, this is a kernel parameter, or on HP it is named max UPRC, and on Solaris below 10. For Solaris 10 or more, the kernel parameter is project.max-LWPS. So status 11 means that we should be increasing the allowed maximum number of kernel processes per OS user. How can we know that? So we have here two useful documents. The first one is helping us to identify the operating system log file. So not all the database administrators have expertise level at the operating system. So if we don't have a system administration assistant, we can go for this document and check the where the OS log file is located. And I would like to show you this document to you. Let me share my browser with you. So here is the document that can help us identify the operating system log. So for example, if we are using Solaris operating system, the OS logs are placed in /var/adm/messages. If it is AIX, here how we can export or extract the OS logs. If it is Linux, it is /var/log/messages. If it is true 64, it is /var/adm/messages. If it is Windows, we can go for the control panel administrative tools and check the event viewer. And after identifying the OS log file, check if there is any error that has been reported in the operating system. At the same time, we are getting the ORA 273 errors in the alert log file. Identify the status for which the Oracle error is raised, as in our example, the status was 11. And then check another very useful document to identify which OS resource, I mean the kernel configuration, corresponds to this operating system operation and error status. And I can show you also this document. So here is this troubleshooting document. As you can see, this is the general form of the error. And then if we go scroll down, we will see all the error statuses are referenced here. So here is status 0. And then here is status 1 and 2 and 3 and so on. As you can see, and each status has dedicated documents that can help you checking which exact OS resource we are lacking of. So check the OS logs, identify the error status, and check the other document to identify which Oracle documents can help you with this specific Oracle status. And check the minimum recommended value for this operating system resource in the online documentation for Oracle for the installation guide. Compare these recommended values to the actual one you have on the server. If they are below the minimum recommendation, please engage your system administrator in increasing these kernel parameters if needed. So we are almost done. We have covered the ORA 20 error, ORA 18 error, ORA 445 timeout message, and the ORA 273 errors. Thank you so much. And you can see here some of the top links and documents we have referenced in this conference. I have written them to you for your reference. And it's back to you, Andrew. Thank you so much.
Thanks, Amir. So I would like to have some Q&A in just a moment. Please use the QA panel on the phone line to ask any questions. You can also use *1 if you're dialed on the phone. While we pause to collect this question, I would like to share some helpful information for you. We would like to invite you to stay connected with Oracle support via our various social media channels listed here. And we have the Oracle product communities where you can post your questions and converse with the subject matter experts, as well as peer from other companies. By the way, my Oracle support blogs where you can keep informed about the priority announcements. And if you'd like to learn more about my Oracle support, since you'll be interacting extensively with the Oracle with my Oracle support, these are all the helpful tools that's available for you to interact effectively. So we have an online help documentation, and we have Oracle Support Essential webcast. You can learn how to use the support portal effectively. And Oracle Support video series provides you with a repository of detailed training videos. Oracle Support Acceleration delivers a targeted learning experience to increase your expertise with the support portal core functions and product-based support tools. So feel free to leverage that. The other thing I want to point it out, as an Oracle Premier support customer, you have access to a wealth of powerful resources to help you proactively manage your business. Please use documentation 431.2 to get proactive and prevent issues, and to contact the team responsible for proactive programs. You can also get a complete view of upcoming events with the Get Proactive Events calendar. This calendar is automatically updated to include current scheduled advisor webcasts, user group sessions, mass essential trainings. So you can filter the visible activities according to the Oracle software products most relevant to you. You can also set up the calendar to display based on your time zone, and all the event time zones will update accordingly. So feel free to leverage the tools available. That being said, I just want to see if there is any calls on the line. Don, do you have any calls?
There are no further questions over the phone at this time.
Sure. Once again, if you want to ask any question, please use *1. I do have a couple of questions show up on Q&A. So, Amir, one of the questions is, how can I/O, that is storage slowness, lead to ORA 445 timeout message?
Okay, thank you for this question. This is very important. So one of the possible reasons we mentioned for the ORA 445 timeout warnings was the slowness of the I/O, simply because we have swap space, and swap space is acting as an extension to the memory, which is the physical memory, and swap space is on the storage. So if we have an I/O problem on the storage, this can also result in the timeout of 445 timeout message, because this could be related to the swap space.
Thanks, Amir. There was also another question on the line that's meeting the minimum recommended kernel configuration. Always avoid ORA 273 errors. No. We can be meeting the minimal recommended kernel parameters that are specified in the Oracle database installation guide, and still get the ORA 273 errors, simply because the operation or the high workload of this database requires more kernel parameter values. So it depends on the workload activity, on how the database is under burden, under workload. So the values that are there in the Oracle database installation guide is just the minimal, but some high OLTP database, heavy OLTP databases require more and more than the values recommended in the Oracle database installation guide. Thanks, Amir. Hey, Don, one more time checking. Is there any other calls on the line?
There are currently no questions at this time.
Sure. Amir, one another question came in on the Q&A panel concerning the ORA 18 error in a multi-tenant architecture. how will the maximum number of allowed sessions be calculated at the PDB level?
Yes, thank you. This is a very important question as well, because in the multi-tenant configuration, we have the sessions and processes initialization parameter at two levels. The first level is the CDB container, the root container, and the second level is the PDB pluggable database level. So basically, the values at the PDB level overrides the values of the session of the CDB root container level. So you should be checking the maximum number of allowed sessions per BDB, and then check the number of maximum allowed processes at the PDB as well. So compare the value of the sessions parameter at the PDB level to the 1.5 processes at the PDB added to 22. So check the value of the sessions parameter and compare it to the default value based on the formula at the PDB level. Whichever is greater, this will be acting as the maximum allowed number of sessions for this PDB, after which we will be raising the ORA 18 if we will be going to, if we are receiving a new session request.
All right, thanks, Amir. So Don, if there is no further questions, I will move on to the next slide.
There are no questions at this time.
All right, thanks, Don. So the other common question that's been raised is, how do I get this PDF? How do I get this presentation? Can I have this session recorded, which is viewable? Or how do I follow up if I have further questions? So let me go through real quick. There is a documentation 740.966.1. We have the details on all our recorded sessions and as well as the upcoming sessions. So feel free to use the documentation. The other choice is you can go directly to your specific product area on the MOS, and you can follow through for all the slide decks. We also created a forum thread. So if you have further questions, feel free to follow the forum. So we hope you found this webcast valuable. Please take a moment to share your feedback on this presentation and the webcast program via the survey that will display when you exit today's event. Let us know what topics you would like to see covered in future webcasts as well. Thanks for Amir and all the panelists to answer all the questions. And thank you for each of you taking time today to join with us. We know you have many demands on your time and appreciate you choosing to spend some time with us to learn more about the Oracle product. This concludes our webcast today. Enjoy the remaining of the day.
This concludes today's conference call. You may now disconnect.